Okay, so number 34 is asking about the same situation as last time. An object is initially hanging in equilibrium from a vertical spring. The object is pulled down 15 centimeters from its equilibrium position as illustrated above, and released at t equals 0. The object then oscillates with a period of 2 seconds. Let x equal 0 be the equilibrium position, and let the positive direction be upward. So what 34 is asking is for the total distance traveled by the object during the first 2 seconds of its motion. So the way we can do this is we can simply add up the absolute value of all of the distance it has traveled. So from 0 to 1/2 second, which is a quarter of its period, we know that it goes up 15 centimeters because it has an amplitude of 15 centimeters. And then as it goes from 1/2 second to 1 full second, it goes up another 15 centimeters because it has traveled another 15 centimeters. And then it's the same thing on the other side. On the way back down, another 30 centimeters, which comes out to 60 centimeters in total. So the way this is shown is usually using calculus. We can not only find where it crosses over the x-axis, which is important because we want to make sure we count negative values as their absolute values, so that we're counting the total distance traveled and not just the displacement. And so we can also find a turning point so that we can make sure we are counting distance when it's going back down as well, because if it becomes a net, then it's not the total distance. So how we might do this: normally we might use calculus to find the derivative of x equals x max cosine of omega t, and then set that equal to 0, because that would tell us where the tangent to x equals x max cosine of omega t has a slope of 0, meaning it would have either a horizontal inflection point as a function or a turning point. And you could figure that out by looking at whether the slope of the tangent was positive or negative. It was positive on one side and negative on the other side, or not. If it were the same sign on either side of the 0 of the derivative, then it would be a horizontal inflection point and not a turning point. But since we have such a symmetrical function here, we are able to just look at it. We can see that it goes up 15 centimeters from 0 to 1/2. We can see that it goes up 15 centimeters from 1/2 to 1, and we can see it's exactly symmetrical on the other side. So it's just 15 times 4, 60 centimeters. So yeah, in our question 34, what is the total distance traveled by the object during the first 2 seconds of its motion? The answer is C, 60 centimeters.